All right, hi year 11, hi year 12s, this is Mr. Lim here, and this is our first video on changes to one chemical species in equilibrium, and let's get started. All right, so what are we going to be learning about? We're going to be learning about which states of matter affect equilibrium and identify what changes can occur. All right, so the idea is that we've learned about equilibrium systems. We've learned what a dynamic equilibrium system is, right? And since we have systems which can be at dynamic equilibrium, they're going to have constant macroscopic properties. The idea is that you can then cause changes to those equilibrium systems, and you have to work out what's going to occur to those systems. All right. So the first change we're going to discuss is changing a concentration of one chemical species within that substance. Okay, so for any equilibrium system, you could change the amount of stuff. You could change the amount of stuff that's in there by adding or removing some stuff. All right. However, adding and removing stuff only affects equilibrium for certain states of matter. Okay, so for certain states of matter. And really, it's only the aqueous or the gaseous states because they have concentrations which affect equilibrium. So the idea is that if you have an equilibrium with a number of different states where you've got like solids, aqueuses, liquids, gases, if you were to add some solid to that equilibrium system, that's not going to affect that equilibrium system, right? Because you're adding a solid and it doesn't have a concentration, it's not going to affect how that equilibrium system in the way that you'll end up with more or less of stuff, other than the stuff that you added. All right. Whereas if you were to add a solid which would then dissolve into that solution, then the concentration of those ions would change, and therefore you would have a change in that equilibrium system, which you would have to work out. All right, so solids and liquids not affecting equilibrium, okay? However, aqueous and gaseous ones will. And that's the reason why in your equilibrium constant and your reaction quotient, you only have concentrations of aqueous and gaseous things, and you don't have solids and liquids inside those equations. All right, so what can cause a change? So the idea is that you can either increase or decrease the amount of one of the substances in that equilibrium system. All right, you can increase it or decrease it. In terms of an aqueous solution, you can increase it by adding stuff to it. All right, so adding stuff to it can come in two forms. You can add in a concentrated solution of whatever ion. Okay, so you might add in a concentrated solution of chloride ions via a concentrated hydrochloric acid solution, right? And that will add in more of those Cl- ions, all right? And you should always take note though that it is usually a small amount because you don't want to change the volume of the solution too much either, all right? So you can add in a concentrated solution of that ion. Alternatively, you can just add in some solid soluble ionic substance with those ions in them. Okay, so again, if you wanted to change the concentration of chloride ions by adding some more, you might add in some sodium chloride, salt, and therefore that would dissociate those sodium ions, and chloride ions would go into the solution, and the concentration of the Cl- ions would increase in that solution. All right, so that's addition. That's nice and easy. You just add something to it. All right. However, getting rid of the stuff or decreasing the amount of ions is a little bit more difficult. Okay, and you can do that via precipitation or neutralization. So neutralization is for your H+ ions or your OH- ions. Okay, so if you have H+ ions or OH- ions in your equilibrium system, you can add in the respective acid or base to neutralize them. All right, that will reduce the concentration of those ions and therefore and just make water, which is a liquid, which then doesn't affect the equilibrium system, and so therefore adding those acids or bases will neutralize stuff, which will reduce the amount of a concentration of those ions. All right. You can also precipitate those ions out. So say you've got Cl minus ions in the equilibrium system. If you were to add silver nitrate solution, the silver from that would precipitate with the chloride and form insoluble silver chloride, which is solid, and therefore it would reduce the amount of Cl minus ions in that solution. Once you've reduced the amount of Cl minus ions in solution, the system will have to do something about that because it's no longer in equilibrium, and therefore you can work out what happens after that, right? But the idea is that you can't just remove ions from solution. You have to get rid of them either via neutralization or precipitation, which is a little bit more trickier when you're looking at a question and it says, oh, here's this system at equilibrium and I just add this random solid. You're like, why are you adding this random solid? This random solid is not in the equilibrium system. It might be a precipitation reaction to remove one of the ions from solution. All right, let's move on. In terms of a gaseous system, right? Increasing is nice and easy in the gaseous state. You just add more of that gas, nice and easy, pump that in. However, to remove some, it's even harder because you have to effectively get rid of that gas without just picking out individual gas particles, which is impossible. All right. So the idea is that you can separate these out by condensation, which is turning the gas to a liquid. However, you can't do that in the reaction chamber because that would be a decrease in temperature, which would be a different change as well. So remember, we're trying to change the concentration of one substance, and that change in concentration might be via condensation, but you'd have to do that outside the chamber. So what they generally do is that they have the reaction chamber with all the gases in here, all right? And then you pipe out the gases, they come out through this way, and then they go through a cooling chamber. And so some of the gases will be returned. Okay, some of the gases will be returned and some will turn into liquid. Okay, so some of the gases are returned, some of them turn into liquid and get piped out somewhere else. Okay, but the idea is that you can decrease the concentration of a gas by cooling it down somewhere outside of the reaction chamber, and then one of the gases will turn into a liquid, and then it can be removed, and then the rest of the gases can be returned, and therefore you have decreased the concentration of that one gas. All right, so those are the types of changes that can occur to change an equilibrium system, which will cause a whole bunch of stuff to occur, which we'll discuss in the next video. Adios.